No.
No, because it's a corner. Excellent. What about at x sub 2?
Yes.
Yes. It's not. It's continuous. It doesn't have a cusp. It doesn't have a corner. It doesn't have a vertical tangent. Awesome. At x sub 3?
No.
Because it's a corner. Awesome. At x sub 4?
No.
Yes.
Because it's not continuous. Excellent.
Okay.
X sub 5?
No.
No, because it's a corner. Awesome. X sub 6?
Yes.
Yes. No corner, no cusp, continuous, no vertical tangent. Awesome. X sub 7?
No.
No, because it's not continuous. Awesome. Okay. Now, again, just to make sure, what is f prime? It will be a function. What will f prime, what is the scope or the usage of f prime? To give us the instantaneous rate of change at any point where the function, I'm going to use a fancy word, is differentiable. Okay, what does that mean? It has a derivative. So functions may or may not have a rate of change. We say they are differentiable or they are not differentiable. A fancy word. It's the same thing. So the function, we don't really write f prime of x is dne. We say the function is not differentiable here. The function is not differentiable when it's not continuous. It's not differentiable at a corner. It's not differentiable when it has a vertical tangent. You don't have to use the word differentiable. You can say it does, it has or it does not have an instantaneous rate of change. That's good enough. But I'm going to say now, that's page 4. So
I have a question.
please.
So back to the graph you were showing us in the textbook, when it is horizontal but continuous, is that gonna have a rate of change?
Absolutely. It's 0.
Okay.
So for example, yes, for example, here, the rate of change, the slope of the tangent line at this point is 0. The slope of the tangent line at this point is 0. 0 is a value. So if you ask me, what is the rate of change of this function at x sub 8? I'll say 0. I can give you a number. So the function is differentiable if I can give you a number. Here I cannot give you a number because there is a vertical tangent. But here I can give you a number, is 0. Here I can give you a number, is 0. Here I can give you a number, is 0. Actually, when the derivative or the slope of the tangent line is 0, we will see a max or a min for the function. Max, local max, local max, local min, local max. A very important point. Okay? Even this one is a local max, but there are a few things that I need to explain about it. Okay. Very good question. What was I doing? Yes. So now, finally, one more time, f prime of x gives the instantaneous rate of change of function f of x when f of x is, and we're using that fancy word, differentiable. In other words, no cusp, no corner, no vertical tangent, and it's continuous. Okay, finally, f prime of x is, I'm coming back to the two concepts that we are talking about. We are going to put them together. Very easy to remember moving forward. The derivative, or if you want, f prime of x, uses these two concepts put together. Of course, the limit is first, and of course, the difference quotient is next. So this is the limit as age approaches 0 from f of x plus h minus f of x divided by h. So this is what it's called, the formal and the only, actually, formal definition of the derivative function Okay, so let's take a look at a few. The difference quotient is clear to us because we've done that. I would like to, oh, I'm sorry, I forgot to share my screen. Okay. I would like us to choose an example from here. Anything you like. Find an equation of the line tangent to the graph of. We're not going to do 3, 4. Just, we're going to pick one. Find the equation of the tangent line tangent to the graph of. If you don't choose, I will. Okay, I will choose 21. So 21 find the equation of the line, So it's f of x equals x squared minus 2x, and this page is 144. And they want us to determine at negative 2, 8. So here's the question. X squared minus 2x. I know the graph, it crosses at 0 and 2. Something like this. We don't need to graph it. I just want to show what I'm trying to do. So there is a point at negative 2, 8, somewhere here, let's say. They want us to determine the equation of this line. Tangent at negative 2, 8. In order to determine an equation of a line, I have to remember y minus y1 equals the slope times x minus x1. I am given the point, negative 2 and 8. There is a big and very important piece that I do not have. What I don't have is the slope. I have the point, but I have to determine the slope. How do I determine the slope? Finding f prime. For what? For this function. I have the function. I find f prime with the definition of the derivative. We've done this so far at the beginning of the class, finding the difference quotient for a function like this. All we have to do now, put the limit in front of it. So I will write f prime of x equals the limit as age approaches 0 from f of x plus h, x plus h squared minus 2x plus h, minus the function divided by h. I hope you remember this because we worked on several problems, even quadratic and other types. The only thing that we are adding here now is what we studied last time. The LIM operator that says the tendency, not the function value. Okay, so we're adding the limit as age approaches 0 from the difference quotient. We will combine like terms, simplify, and so on and so forth. Remember, two things have to happen. Anyone remembers what has to happen here? Mandatory. What has to happen? There are two very important notes that we wrote 2 weeks ago. Anyone, please? Anyone? What has to happen in the difference quotient? When we calculated and simplified it, two things happened. What are those? Anyone?
All the x's have to cancel out.
No. Remember, terms without h. Terms without h have to cancel. That's the first one. Awesome. Okay. So, can anyone square this for us?
X squared plus 2xh plus h squared.
Thank you so much. You made me very happy. Excellent. Thank you. So these terms have to go away. If others go away, even better. So now, what is the next step? What has to happen next? Mandatory. We got rid of all terms without h. Now we know something else has to happen. What is the second step? How would you continue?
Dividing them by the h, so you
We
get
factor. You can divide, I accept that, but it's better to factor. So we factor out h. What is left in parentheses? It's not a mistake to factor, to simplify. But you have to separate. I don't want my students to cross this with this and then the whole thing collapses. But if you know what you're doing, I'm fine. So what is left, please, in parentheses?
Uh,
2x plus h plus 2. Or minus 2, sorry.
Perfect. Awesome. Good. Now this is a polynomial. Can anyone tell us the limit? If you want, I can write it again. Limit as age approaches 0 from 2x plus age minus 2. What is the final answer when age approaches 0?
2x minus 2.
That's it. This is it. So what have we accomplished here? A lot. F prime of x equals 2x minus 2 for the original function, which was x squared minus 2x. So I'm back to this. I need to determine the slope. So at this point, right here, the slope of the tangent line, so the slope of the tangent line at x equals negative 2 is f prime of negative 2. Is the function, the derivative function evaluated at negative 2. So from here, f prime of negative 2 is negative 4 minus 2, negative 6. So we determined the derivative function. We plugged in the x value to determine the slope. Now I have everything. So I have y minus 8 equals the slope, which is negative 6x plus 2. Y minus 8 equals negative 6 times x plus 2. So what is this? It will give us the equation of the tangent line at the point negative 2, 8. That's what they were asking us to determine. I have to solve for y. So y equals negative 6x, and this is negative 12 by plus 8. Negative 12, and I have to bring positive 8 to the other side. So we determine the equation of the tangent line to the graph of the given function at the particular point. Notice that in algebra, you would have never been able to determine this because you were not given 2 points. You can be given 2 points because this is the tangent. The tangent does not cross the graph in 2 points. It's tangent. It touches it in 1 point. So algebra will have not worked here. Any questions on this problem? Any questions? Okay, I will move on if you don't have questions. Are the steps clear on this problem?
yes, they're clear.
Thank you, Jess. Anybody else needs help?
Can we by chance do one more?
Absolutely. So the difficulty here is to find the difference quotient. While you understand how to find the difference quotient, the rest is a piece of cake, putting the limit in front of it. So you want to choose a different type of function, like 2 over x. Is that okay?
Yeah, that would be good.
Okay, so let's take a look at 19, and f of x is 2 over x, and the given point is 1, 2. All steps are identical. I have y minus y1 equals the slope times x minus x1, where I have x1 being 1 and y1 being 2. The question is, how do I find the slope? Anyone can tell us? Put us on the right track. How do I find the slope? The slope at 1. So the slope of the tangent at x equals 1. Tangent at x equals 1 is f prime of 1. I cannot determine f prime of 1 before I find f prime of x. This is our first step. Finding f prime of x and then plug in 1. If I find f prime of x, which is a new function, I plug in 1 and I determine the slope that I need at x equals 1. Now, can anyone tell us how to find f prime? That's page 6. How do I start in calculating f prime? Can anyone give us the definition of f prime? It's 2 concepts put together. How do I find that? Can anyone dictate? Can anyone dictate the formula for f prime, the only formula we have, or formal definition we have?
Would it be limit when h reaches to
Approaches 0 from the difference quotient. Perfect. That's all I needed. That's perfect. Thank you, Jess. So limit as h approaches 0 from the difference quotient, f of x plus h minus f of x divided by h. Our function in this problem is 2 over x. Okay, so this is limit as h approaches 0. 1 over x plus h minus 1 over x divided by h. Remember our function? Oh, it was 2. Our function is 2 over x. What do we need to find next? We had examples like this in the difference quotient. We did not have the limit in front at that time, but we had the same type of problem. What is the next step here? What do we need to find? What do we need to find, please?
Do we need to make the denominators like a common denominator?
Yes, excellent, perfect. Can anyone tell us what is the least common denominator? In the numerator, of course.
Is it x?
X plus h.
Okay. If I have 1/2 minus 1/3, how do I find the least common denominator? What is the answer? Is it 2? Is it 3? Is it 5? What is it?
It would be 6.
Of course. Why is it 6?
Multiply them together.
Exactly. And because they have nothing in common. If they don't have anything in common, we have to multiply them. So the least common denominator is 6. And of course, 2 times what is 6? We need to multiply by 3. 3 times what is 6? We multiply by 2, and we get this. Okay, so coming back. What is the least common denominator? They have nothing in common. There are no common factors of x and x plus h. Nothing. They're carved in stone. No one can touch them. They have nothing in common.
X times x plus h.
Thank you very much. It's the only way. It has to be the product. So then this one needs to be multiplied by x, and this one will be multiplied by x plus h. Mandatory. Good. So then I have 2x minus negative 2 distributed to x, negative 2 distributed to h. Yes, this has to happen. All terms without h have to go away. Then I copy the numerator, which is negative 2h divided by x, x plus h. I have to flip h over 1 because I'm dividing two fractions. The second step has to happen. If it doesn't, then I'm in trouble. So finally, I have limit as h approaches 0 from negative 2 over x times x plus h. Finally, apply the limit. Remember, I cannot drop the limit operator. I never drop the limit operator till I apply it. This is the only step when I apply it, so it will disappear. Do not drop the limit operator till the final stage. Can anyone find this limit as h approaches 0? The limit as h approaches 0. H approaches 0. What is left?
X squared.
Negative 2 over
It would be negative 2 over x squared.
exactly. Negative 2 over x squared. So we found the derivative. It's negative 2 over x squared. But I'm interested to plug in the derivative 1 because the slope is f prime of 1. So then how much is f prime of 1? This is f prime of x. How much is f prime of 1?
Negative 2.
Excellent. Perfect, thank you. So then all I have to do is write my equation. Y minus 2 equals negative 2 x minus 1. Combine like terms, negative 2x. This is positive 2, and I bring another 2. This is the equation of the tangent line to the graph of this function at this point. So how fast is this function changing at 1? It's decreasing because it's negative, negative 2. How fast is this function changing at 1? Negative 2. That is the slope of the tangent line at this function at 1. Now, I know you're going to ask, are we going to do or apply the difference quotient all the time? No. No. This is to remember what the derivative is. It's a combination of two concepts put together, very important concepts.